Okay, it's recording. We'll see. The microphone might not pick up when I walk back and forth, so there's not going to be any kind of clean video here. I've got a potential, an equation for the potential, and I was asked to find what is the electric field in every direction. So I have a general equation for potential. My general equation for potential is E, and finding field from potential, E equals negative dV ds. Okay? This is for finding the electric field in 3 dimensions. To do that, I kind of need to take the derivative, but I need to do it in each direction separately. So I don't take full-on derivatives, I actually take partial derivatives. So to get Ex, the electric field in just the x direction, I use this squiggly d. That squiggly d stands for the partial derivative of E with respect to whatever variable you want. So I want the electric field in the x direction. So what variable do I differentiate with respect to? With respect to x. So x is the only variable in this equation according to this derivative. Every other letter that I have in there, I might as well assume it's a number. Okay? So I don't have to do anything for taking the derivative of y or the derivative of z. So let's do this. How do I take the derivative of this? I have some rules. I have some particular rules that I could follow. This is a quotient, right? I have one number divided by another. I could use the quotient rule. How many of you like the quotient rule?
No.
For those watching on YouTube, nobody rose their hands. Nobody likes the quotient rule. The quotient rule is stupid. Oh, somebody just said I do after I called them stupid for thinking that. Sorry. It's okay, they had brain surgery. I'm talking to YouTube as we present. This is how my physics channel is number 39. Okay, so I can rewrite this. So I can take the derivative of this v. If I rewrite v is equal to this x, and then to make this product, I can do x squared plus y squared plus z squared, and I can instead raise that to the negative 3/2 power. It's the same exact thing. I just made the exponent negative to bring the denominator up to the numerator. And now I can use the product rule. Do you remember the product rule?
Yeah, f prime times d plus f times d prime.
If I have 1 times 2, then the product rule tells me that I do the first times the derivative of the second, 2 prime, plus
1 prime.
the second times the derivative of the first. Okay? When I learned this, do you know when did I learn this? What do you think? What grade?
5th grade.
Fifth grade? No. Middle school? No. I learned this in high school, and the teacher was a chorus director too, so she always sang every formula. So I always remember this as she called this a rap.
What?
Yeah, she called this a rap. The first times derivative of the second plus the second times derivative of the first. Yeah. She just tossed the word yeah, and that made it rap.
Wow.
Yeah, she was a very white lady. Okay, let's keep going with this. Let's take the derivative of all of this equation. Okay?
Oh, that's so cool.
So we'll shrink that down. I know it's amazing, isn't it? No, you're not having seizures. Okay, so I need to take the derivative with respect to x of x times x squared plus y squared plus z squared to the negative 3/2. So to take this derivatives, to find my ex, remember we've got that negative floating out front. Ex is going to be equal to the negative derivative of all this. So I take the first. What's the first thing I have there? X. So the x just stays right there. And then I have to take the derivative of all of this second part. So I have some stuff in parentheses raised to a power, raised to an exponent.
Oh.
Bless you? I think.
Sorry.
That needs 2 crosses. Okay, so I have to take the derivative of this second part. It's some stuff in parentheses raised to a power. What rule can I use to take that derivative? The power rule. That's why I keep saying the word power. So we take the exponent, whatever you have for the exponent comes down in front in the power rule. So we bring that down front. -3/2. And then whatever is in parentheses just comes right along for the ride. X squared plus y squared plus z squared. And then I have to take that exponent, and what do I have to do to it?
-1.
I have to subtract 1 from it. So I have to do -3/2 minus 1. And then what do I have to do? The thing that most people always forget for the power rule, you have to take the derivative of what's ever inside of the parentheses too. So I have to take the derivative of all of this. What's the derivative of all that? 2x. I heard some people say 2y and 2z, plus 2y plus 2z.
No.
Now I'm hearing people say no.
Partial derivative.
What do I do? No? I'm confused.
Just 2x.
I heard somebody say because these are numbers, right? Y and z are basically numbers as far as this is concerned. Why are they numbers? We'll put that in quotation marks. They're numbers because the only variable when I'm taking this derivative is x. So y and z, they're numbers. Might as well assume they're the number 1. Derivative of 1 is 0, so we have no y or z that go along with that. Okay? Let's make a little more space. We try to make it a little cleaner. God, if anybody watches this on YouTube, I feel sorry for them. Okay, is that it? Am I done?
Yes.
That was the first times the derivative of the second part. What do I have to do now? Plus the second part. What's the second part? X squared plus y squared plus z squared to the -3/2. So that's the second times the derivative of the first. The first is that x. What's the derivative of x? 1. So I've got the first times derivative of the second plus the second times derivative of the first. Yeah. You have to say it jazzy, though, and you have to do jazz hands.
That's not a rap.
Yeah, she thought it was. Very old white lady. Okay, so this is our answer. This is the electric field in the x direction. We have the negative of all of this. Can I simplify it?
Yes.
Yeah, I can combine like elements. I could simplify this, make it look a little bit nicer. Do I have to?
No.
Do I care if you do? No, because I'm the nicest professor in the world. I don't really care. But you can simplify it. Okay? If we did simplify this, what would it look like? I'd have a 2 here that cancels with this 2. My x's would combine to give me x squared. This negative would cancel with this negative, but then it would go into this negative. Right? My -3/2 minus 1 gives me -5/2. So simplified, this would look like 3x squared times x squared plus y squared plus z squared to the -5/2 minus x squared plus y squared plus z squared to the -3/2. There's my very funky electric field. Any questions on that? Yes? I would give you an equation, and I would, for potential, and say find the electric field in all the different directions. Same as I asked on the quiz.
And this is in all directions.
So this isn't the entire problem yet.
X.
This is the x direction. So if I want to do another direction, how do I do another direction?
The same way.
You just do different variables.
Same way.
Z.
Oh goodness. Shrink this down a whole bunch. And then move it away.
There's only 3 directions.
There's 3 directions, so I would have to do EY. How would I find EY? Partial derivative of V, negative partial of V with respect to what?
Y.
With respect to Y. Do you want to do that one?
I have a question.
Yes.
In one of the last homework questions, I had a question like this, but you didn't use the product rule. You just took the derivative of the first. Why is that?
Probably because there wasn't a product to take the derivative with respect to.
No, it was still like x over x squared plus y squared.
So let's do it for Y, right? So what was the equation for V again? I shrunk it down to the point where I can't see it.
V equals x over x.
Partial with respect to Y of x. Okay.
Over x squared plus y squared.
Okay. X times the x squared plus y squared plus z squared
Yeah, to the 3 times.
to the negative 3/2 if I'm bringing it up top.
Right.
Right. Yeah. Okay, so I think this will answer your question. So if I take the derivative of this, I have the first times the derivative of the second, right?
Yeah.
So I take the first, which is x. And now I need to take the derivative of the second part. That's all this stuff over here. So I again use the power rule, right? My negative 3/2 comes down in front, and then I multiply by the parentheses, so I have my negative 3/2 times x squared plus y squared plus z squared to the negative 5/2. Then I need to take the derivative of whatever is inside of the parentheses. What is the derivative inside the parentheses? Do I have to do anything with the x squared? Nope, it's just a number. Its derivative is 0. So I just differentiate the variable that I'm got in my partial derivative. So that would be 2y. Do I have to do anything with the z? Nope, just a number. Okay, so that's the first times the derivative of the second. Yeah? Plus the second. What's all the second stuff? I've got the x squared plus y squared plus z squared, all raised to the negative 3/2, times the derivative of the first. What's the derivative of x with respect to y?
0.
0. It's basically a number.
Oh.
So all that second part goes away.
Okay.
And there is my, basically my final answer for EY. There's a negative that goes along with that from the definition of E in potential. Yeah? So x, since x is, I'm taking the derivative with respect to y. So in this case, y is the only variable. If y is the only variable, then x is basically just a number. If it made you feel better, you could plug in the number 1 for that. So then I take the first times the derivative of the second plus the second piece right here times the derivative of the first. If that's a number, then the derivative of a number is 0. 0 times this makes it go away. Disappears. Okay. Any other questions on this one? And then if I had to do this in the z direction, turns out the z direction I get the exact same thing as y. So anywhere you see a y, just replace it with a z. Yeah? Make sense? On an exam, is this a good exam question?
Yeah.
Yeah, is it a full point exam question? How many points do you think this is worth? 0.5? 5 points, you think? No, this would be like a 20-point question. This is a full question. Why is it a full question? You have to know how to take derivatives. It's calculus. I know that you're not all experts in calculus. I'm not either. Better than anybody else at this university.
What about category?
Oh God, that's recorded. Not better than the math professors. Maybe. And not better than Kathy. Yeah.
So our final answer is just
EX, EY, easy. Okay? No questions on that?